if we want to implement the quantum Fourier transform of a single qubit problem in qiskit. To do that, we just need to open our qiskit, or to open the Jupyter lab or notebook in qiskit, just like you can see here on my screen. And to start, we first need to import from the qiskit library some packages that are required to implement a quantum circuit. The first one is we have to import here is the QFT, which is a package that is needed to implement the quantum Fourier transform in qiskit. We are fortunate that this has been already implemented and incorporated into the qiskit library. But if you need to build your own quantum Fourier transform package, just let me know in the comment section, and we can do another video to show how step by step you can build a quantum Fourier transform for 1 qubit or many qubit as you want. But for instance, let's say we want to import the quantum Fourier transform package from qiskit library. To do that, we just need to type from qiskit qiskit .secret.library import QFT. And to extract the state vector of the secret that we will have to create, we need another package called a state vector simulator. And to import it, we just need to type from qiskit the quantum info import state vector. And another package is the quantum secret itself that we need to build. And to import this quantum secret, we need to just type from qiskit import the quantum secret, and then we can run to make sure that this has been correctly imported. These are the 3 packages that will be required to implement our quantum Fourier transform, for instance. Another one is the package to visualize the Bloch vector that we will plot, and this one is imported by just typing from qiskit the visualization import Bloch multivector, and we also want to make sure that it has been correctly imported. Now let's assume that we have to implement the quantum Fourier transform of this vector, of this state. Let's say we have this state that we want to implement its quantum Fourier transform. Here it means that we have a state with 3 qubit, where the first qubit is in the 0 state. The first qubit, because you have to start from right to left. The first qubit here is in 1 state, the second qubit in 0 state, and the third qubit in 0 state also. So we therefore need to create a quantum secret of 3 qubits just by typing QC equal quantum secret of the length of our state here. And we recall that the length of this state is 3. Then we are creating here a quantum secret of 3 qubits. And therefore, to extract the state vector of this secret, we just need to type QC dot. Then we use the initialize command to extract the state vector of the secret we have just created. And this now, from here, we are sure that we have our state vector. Now, to see the Bloch sphere of this vector, we just need to use the display command, and by typing just display Bloch multivector of the state that we have created previously. And if we run it, we realize that we have the Bloch vector of our quantum state that we created above, which you can see here, the Bloch vector of this state. It shows that the first qubit is in the 1 state, the second qubit is in the 0 state, and the third qubit is also in the 0 state. Now we want to implement the quantum Fourier transform of this state, and to do that, we just need to apply the quantum Fourier transform package that we imported earlier just by typing qc dot, then we append. We use the append command to implement the quantum Fourier transform. Then we set the do swap to true to make sure that we swap the first and the third qubit. And because this is how we implement the quantum Fourier transform of a quantum state. And to display the blood sphere of this of the state that we create using after applying the quantum Fourier transform, we just need to type display just as in the previous case. Let's say display, then we plot the blood vector of the secret after applying the quantum Fourier transform. And if we run the cell, you can see here that we have the state, the blood vector of our state. We show that the first qubit which was initially in the one state, after swapping the first and the three, the first qubit now is in the zero state. Therefore, after applying the quantum Fourier transform, we obtain if the qubit is in the plus state, the second qubit is also in the plus state, but the third qubit is in the minus state. As